Got Ebola, bird flu, MERS. It seems like every week there's a new outbreak of some new disease. And the whole reason why they're dangerous is because they can spread from person to person. Cancer, on the other hand, never seems to cause the same kind of widespread media panic because you don't generally hear about outbreaks of cancer. But people with other deadly diseases can spread them to you, so why should cancer be any different? Cancer is what happens when a normal cell's genes make it grow too much. It's an inside job, unlike all those other infectious diseases that are carried by other people. And it can spread within a patient's body when stray cancer cells latch on in new places and keep growing. But as long as you have a working immune system, you can't catch it from someone else. At least not unless you're a dog, a Tasmanian devil, or an unbelievably unlucky human. Your immune system's job is to detect and destroy invaders like viruses, bacteria, and cells from other humans. So if someone else's cancer cells get into your body, your immune system will realize it's not yours and destroy it before it has a chance to spread. Your immune system identifies things based on what's known as the major histocompatibility complex, or MHC, one type of little protein flags that all cells, including cancer cells, have on their surfaces. Someone else's cells will have different flags from yours, so they'll look all wrong to your immune cells. MHC flags check in with the immune system on a regular basis. If the immune system sees the flags it's expecting, great. If not, it kills the imposter. That's why people who get organ transplants have to take immune-suppressing drugs. Humans all have very different MHC protein flags, so it's our best defense against contagious cancers. But animals that are less diverse than us have it pretty rough. For those species, there is such a thing as contagious cancer. Consider the dog. You know, man's best friend, 4 legs, catches tumors from other dogs. Specifically, dogs can get cancer from sexual contact with other dogs, or by sniffing each other's genitals, which, as you may have noticed, is not particularly uncommon. It's called canine transmissible venereal tumor, and it's the exact same tumor that's been passed among dogs and wolves for as long as 2,500 years. A long time ago, some wolf developed a tumor whose cells had the ability to latch on to other wolves and live there, and scientists think that same population of cells has been spreading ever since. This weird disease accomplishes this through a neat trick. The tumor cells decrease their MHC flags so that they have fewer of them, but not none. If they had a full set of flags, the dog's immune system would reject them. If they had none, the immune system would pick up on that too. With just a few, the tumor is a lot harder to detect. But if the vet tells you that Fido has CTVT, don't freak out. A healthy dog's immune system will almost always reject the tumor, eventually, and after that, the dog is immune to future cases of CTVT. Its immune system remembers and doesn't fall for the tumor's tricks a second time, but in Tasmanian devils, the situation is not as great. Devil facial tumor disease is virulent and almost always deadly, and conservationists are desperate to find a cure because it is a threat to the existence of the species. Unlike CTVT, it's brand new, dating back to only 1996, and it's grown to an extinction-level crisis. It spread from mouth to mouth by biting in courtship and fighting, and you can't explain to a Tasmanian devil that it should please not do those things anymore because those are a Tasmanian devil's favorite things to do. DFTD cells are much more dangerous than the dog version because they've eliminated their MHC flags altogether, and for some reason, the devil immune systems just seem to ignore them completely. But there is some hope in the form of a vaccine made of dead DFTD cells. The vaccine introduces the tumor cells to the devil's immune system, but they can't multiply. The idea is that just like with the canine tumor, the next time the devils encounter the cancer cells, they'll be ready. But I have good news for you. Cancer cannot spread this way in humans. Contagious tumors probably developed in dogs and Tasmanian devils because both species are relatively inbred. Since their genes are so similar, protein flags in their cells look kind of the same, and these tumors are much harder for their immune systems to detect. Humans, on the other hand, are so diverse that tumors haven't developed ways to spread from person to person like an infectious disease. Our immune systems have the situation under control. But there is an indirect way for cancers to spread between humans. In this case, it's not the cancers themselves that spread, but the infectious agents that cause them. Cervical cancer, for example, is caused by the human papillomavirus, or HPV. Most of the time, the immune system clears up the HPV infection before it causes cancer, but sometimes the infection sticks around and the viral proteins encourage cells to grow more than they should. Eventually, those fast-growing cells can become cancerous. HPV is sexually transmitted, and while it usually causes cervical cancer, it can cause cancer in any tissue it can infect, including the mouth and throat, penis, and anus. But there are several vaccines for HPV already, and the Centers for Disease Control and Prevention encourages people to get vaccinated whether they have a cervix or not. The vaccine doesn't prevent the cancer, though. Instead, it prevents the virus from gaining a foothold in the first place. So while HPV vaccines do prevent cancer viruses from spreading and prevent cancer in people who are vaccinated, they don't have much to do with cancer cancer in the strictest sense. They work just like vaccines for other viruses by showing your immune system what the virus looks like so it can remember and kill the thing. But HPV isn't the only human cancer virus out there. For a long time, Kaposi sarcoma was rare throughout most of the world, though it did crop up in parts of Africa and the Mediterranean. It was virtually unheard of in North America until the AIDS epidemic. Kaposi sarcoma is caused by a virus called human herpes virus 8. The virus has borrowed a few human growth genes over the course of its evolution, and when it infects a cell, those growth genes get inside and tell the cell to grow way more than it should. HHV8 is spread via saliva and other bodily fluids, and it's infected a good portion of the population, less than 10% in North America, but probably more than half of the people in Africa. Most of the time, though, the infection is so harmless that people don't even know they have it. So why doesn't it cause cancer unless you have AIDS? Well, the immune system keeps both HHV8 and the cells it's infected in check, but in AIDS patients, the immune system is taken out of play. Since nothing is slowing the growth of the HHV8 infected cells, they become cancerous. And there's another group at risk for Kaposi sarcoma: organ transplant patients who usually have their immune systems suppressed by drugs so that they don't recognize a donor organ as foreign and reject it. If the HHV8 virus is around, it can take advantage and cause cancer, but if immunosuppression is stopped, the immune system can kick back in and the cancer may go away. The immune system fights these cancers the same way it fights any other infection, by recognizing foreign protein flags and eliminating infected cells. And the existence of the HPV vaccine means that we can try to prevent other viral cancers too. By looking at the genetics of tumor cells, we can tell whether cancer cells have mutated a way around detection by the immune system. And by studying microscopic slices of tumor, we can tell whether certain types of immune cells are fighting it. This way, we can help our immune systems help us. One form of therapy involves harvesting immune cells from the patient that are already attacking a tumor, supercharging them in the lab, and then putting them back into the patient. There's also interest in developing tumor vaccines to help the patient's immune system recognize and fight their cancer, and some of these are already in use. But in situations where cancer is caused by a virus, it's never the cancer that's communicated from one person to another. It's the virus that's shared, and unlike the dog tumor, the cancer that the virus causes starts from square one every time, brand new from each person's cells. Cases of actual cancer spreading from one person to another are rare enough to rate as freak accidents, but it does happen every once in a while. The most likely scenario is, once again, transplant recipients. If a donor has an undetected cancer, usually melanoma or some form of blood cancer, some of those cells can hitchhike along with a donated organ. Normally, of course, the recipient's immune system would shake them right off, but it would also shake off the organ. In cases like this, the organ has to be removed from the patient so that the patient's immune system reasserts itself and the cancer goes away. A pregnant person can sometimes transmit cancer to cells in the fetus, and there's at least one case of a surgeon getting cancer from a patient in a weird fluke of probability. He cut his hand while it was inside the patient. But this kind of thing won't happen from just hanging out with someone who has cancer, of course, which means that we can safely consider cancer a non-contagious disease and shouldn't be any more afraid of catching it from someone else than we are of, say, falling into a radioactive chemical spill and becoming a superhero. Thank you for watching this episode of Scishow, which was brought to you by our patrons on Patreon. If you want to help us keep making episodes like this and educating the world and also you can go to patreon.com/scishow. And if you just want to keep getting smarter with us, just go to youtube.com/scishow and subscribe.